Hello children, hope you are doing well. Welcome to Electron Chemistry Center. This is VKM. It's been a long gap. After 4 days of a gap, I am actually doing this session, as you know. But anyway, we will continue the P block elements session. We will try to complete the group 15 elements as early as possible by the end of this week if possible. In the previous lecture, if you observe children, in the previous lectures, we had started group 15 elements. Group 15 elements we had started. We had discussed about nitrogen, preparation and properties is done, as well as ammonia, preparation properties are also done, right? So now followed by a very important topic or a subtopic for today's session, that is about nitric acid. So nitric acid, most familiar acid, most of the people are familiar about this acid. Formula is HNO3, also called as aqua fortis, also called as aqua fortis. It means strong water. It means strong water, right? You are not supposed to drink it. Okay, so water is there in the sense it is not supposed to be used for drinking. Don't do that. Yes, I'm kidding. So aqua fortis means strong water. So in today's session, we will be talking about nitric acid preparation and properties. Preparation and properties. Very important chemical reactions we are going to talk about, along with the group 15 tricks also, as well as we will be talking about brown rings test, which is most important test even for practical examinations also, right? And most important reactions of nitric acid also will be discussing in today's session. Don't miss it. Watch it till the end. If you like the video, you can click on the like button. If you have any doubts, meanwhile, you can post it in the live chat, or else after the completion of the premiere, you can post it in the comment box also. And if you haven't subscribed to my channel, please subscribe to my channel. And if you have already subscribed, please click on the bell icon. Without any delay, we will go into the session. Let's move on. So nitric acid, how can you prepare? First of all, laboratory method of preparation of nitric acid, if you observe it. Sodium nitrate, whenever it is treated with H2SO4. This is the first preparation method we are going to talk about. It is laboratory method. Sodium nitrate, instead of sodium nitrate, you can take even potassium nitrate also. Potassium nitrate or sodium nitrate treated with H2SO4 gives sodium hydrogen sulfate plus nitric acid. Sodium hydrogen sulfate plus nitric acid. So this is the laboratory preparation method. Of course, nitric acid which is prepared by this method is always consisting of some amount of water. In such cases, it can be removed by treating it with P4O10, phosphorus pentoxide. It can be acting as a dehydrating agent. It can be acting as a dehydrating agent. So by using this dehydrating agent, we can remove the traces of amount of water. Understood? But commercially, so on a large scale or an industrial scale, it can be manufactured by a process called as Ostwald's process. By a process called as Ostwald's process. A very important process, children, for any board examinations, and they will ask you a question. Write the chemical reactions involved in the manufacture of nitric acid by Ostwald's process. Right? So preparation of nitric acid on a large scale or a commercial scale or industrial method, right? Whatever you can say. By which process? Ostwald's process. So in Ostwald's process, if you want to manufacture, nitric acid, we will use ammonia. Ammonia, if it is undergoing catalytic oxidation. Step 1, we can say catalytic oxidation of ammonia. Step 1 is catalytic oxidation of ammonia. When ammonia undergo oxidation in the presence of a catalyst, that is platinum or rhodium gas. RH stands for rhodium, right? So you can use platinum or rhodium gas catalyst at 500 Kelvin. Actually, we can use very high temperature, right? It is around more than 1000 Kelvin also we can use it, and it gives nitric oxide plus water, and this reaction is exothermic reaction. So delta H is highly negative. Delta H is highly negative. So we got nitric oxide. So this nitric oxide is a raw material. This nitric oxide is the raw material. By using this nitric oxide, we have to prepare nitric acid. In step 2, what we will do? Oxidation of nitric oxide. So nitric oxide which is obtained here, it must be cooled and oxidized. Step 2 is oxidation. NO plus O2, which gives you NO2, nitrogen dioxide, you will get it. Okay. So once you get the nitrogen dioxide, and that nitrogen dioxide should be treated with water. It gives you nitric acid. So if you just see that, generally a flow chart, how does it looks like? It gives a general idea for you. So here we will be introducing NH3 plus air. So here we will be arranging platinum gas or rhodium gas. We will be arranging a platinum gas here. So it is called a catalyst tower. And that catalyst tower, right, through this what will you get it? It is connected to a cooler. And that cooler is connected to oxidation chamber. Okay. So in this catalyst tower, step 1 takes place. In catalyst tower. Now NO will be obtained here. That NO must be cooled and send it to oxidation chamber. This chamber is called oxidation chamber. In this oxidation chamber, what will happen? NO plus O2. Nitric oxide can be oxidized to nitrogen dioxide, right? And later on it must be passed. It must be connected to absorption tower. Children. Where it is connected, this tower is called absorption tower, right? So in this absorption tower, if you observe it, there is an inlet for sprinkling of water. Water can be sprayed here, right? So if any waste gases will be there, and those waste gases can be removed out. There. So whatever we got the nitrogen dioxide, it must be introduced to absorption tower. In that absorption tower, actually, which is packed with acid proof stones. Will be there. Okay. So, and the water can be sprayed from the top. This is water. Water can be sprayed from the top, and when water can be sprayed from the top, what will happen? Dissolves the NO2, which we got it here, in the presence of O2, which gives about 60 to 68% of nitric acid will be obtained here. Understood? NO2 plus H2O giving rise to HNO3. These are the chemical reactions are involved in manufacture of the nitric acid. Manufacture of the nitric acid. Hope you understand, children. So of course, nitric oxide, whatever we got it, observe it there. Just check the diagram carefully. Everyone, please check the diagram carefully. I'll be erasing it, right? So now NO also we got it. This NO can be recycled. Once again, it must be oxidized. It must be oxidized to get NO2. That can be recycled also. Understood? So here, whatever we got aqueous nitric acid, nitric acid means that nitric acid is having some amount of water. Around you will get 60% of nitric acid, and that 60% of nitric acid must be distilled to get the 68% of nitric acid, almost 68% of nitric acid. Still large amount of water is there, so we should treat it with concentrated sulfuric acid. Concentrated sulfuric acid can act as a dehydrating agent. It can act as a dehydrating agent. So what will happen? So once this any amount of water is pending, that also can be removed. It will give you 98% of the nitric acid. It gives you 98% of the nitric acid, and that nitric acid is nothing but pure nitric acid almost. Is it clear, children? Right? So concentration can be done by treating it with concentrated sulfuric acid by a dehydrating agent. So what will happen? So that concentrated nitric acid, you will get it by distillating that 68% of nitric acid. Understood the point, children? So all the water molecules has been removed. Clear? Now let's see the structure of nitric acid. So HNO3 is a planar molecule, children. It is a planar molecule that you can observe. Planar molecule in the sense, generally sp2 hybridized molecules are used to having planar shape. Such a way, nitric acid also is having planar shape, and bond length between OH bond length is 96 picometer, ON bond length is 140.6 picometer, whereas bond angle between HON is 102 degree. And here when it comes to NO bond length, it is 121, and here this bond angle can be taken it as 130. That bond angle can be taken it as 130 degree. Is it clear? So this is the data can be given for nitric acid. Understood? Yeah. Simple MCQs. Nitric acid is commercially prepared by which process? Commercially it can be prepared by which process, children? By Ostwald's process. Contax process can be used for manufacture of sulfuric acid. Haber's process is used for manufacture of ammonia. Ostwald's process is used for manufacture of nitric acid, children. The catalyst used in commercial preparation of nitric acid: platinum or rhodium gas. RH stands for rhodium gas, metal gas. In the structure of HNO3, ONO bond angle is 130 degree. Now there is a laboratory preparation method, as I told you first, that is a substance which is reacting with H2SO4 giving nitric acid plus dash. Okay, so obviously answer is NaNO3 and NaHSO4. Here NaNO3 and here NaHSO4, sodium hydrogen sulfate. Clear? Now the most important part we are going to talk about, it is reactions of nitric acid. Reactions of nitric acid. So generally, if you observe with children, when you talk about nitric acid, see, it is acidic in nature. It is acidic in nature, as you know. Why? Because it can provide H plus ion. It can provide a H plus ion. So if it provides H plus ions, means it can react with bases to form salt. It can act as a acid. And second set of reactions are oxidizing nature. Oxidizing nature. These are very important reactions for us for both board as well as competitive. Concentrated nitric acid can act as a strong oxidizing agent. Concentrated nitric acid can act as a strong oxidizing agent. OA stands for oxidizing agent, not overaction. Okay. So we can categorize the reactions. And third category, it can act as a nitrating agent also. Means it can behave as an acid, it can behave as an oxidizing agent, it can behave as a nitrating agent also. But most important reactions for us is oxidizing nature reactions. So it can behave as a strong oxidizing agent. Why? Because it gives nascent oxygen readily. Like if you take it nitric acid, it gives H2O plus 2NO2 plus a nascent oxygen. Because of the releasing of nascent oxygen, it can act as a strong oxidizing agent. So during oxidation reactions, these two products are always same. Remember that. These two products are always same. For suppose, if I take still more concentrated and 2NO plus 3 nascent oxygens, you will get it. Still more concentrated, you will get nitric oxide plus H2O and 3 nascent oxygens you can see. Is it clear for you? Right, children? So let's talk about it. So especially when we talk this reactions of nitric acid with metals. So with metals, generally there are different set of reactions we have. But before discussing metals, I'll be talking about oxidizing reactions here. As I told you, HNO3 can act as a strong oxidizing agent. What it will do? It will convert H2S to S, hydrogen sulfide to sulfur, as well as sulfur dioxide to H2SO4. Similarly, it can convert Fe2 plus to Fe3 plus. That to acidified Fe2 plus can be converted to Fe3 plus. And if you take HBr, Hi can be oxidized to Br2 and I2 respectively. Okay, so I minus can be oxidized to I2. Same thing, it is I minus can be oxidized to I2. As well as SN2 plus can be converted into SN4 plus. SN2 plus can be converted into SN4 plus in which medium? In acidic medium. Right? SN2 plus can be converted into SN4 plus in acidic medium. Understood? So similarly, if you take ferrous sulfide can be converted into or oxidized to FeSO4. Understood? So FeS can be converted into FeSO4 also. And as well as cane sugar can be converted into oxalic acid. So cane sugar, what is the formula? C12H22O11, and it is treated with nitric acid. And it gives you oxalic acid. And you will get byproducts as NO2 and H2O. Hope you understand it. So cane sugar can be oxidized to oxalic acid by the help of nitric acid. So in these reactions, nitric acid is acting as a oxidizing agent. You can write reactions very simply. So if I take HNO3 plus H2S, what it will give? NO2 plus H2O plus S. Means H2S has been oxidized to. S. Yes or no, children? Okay. So it has been oxidized by nitric acid. Similarly, you can take SO2 to H2SO4. Means HNO3 reacts with SO2. It can be converted into H2SO4 plus NO2 will get it. Similarly, Fe2 plus can be converted into Fe3 plus, HBr to Br2, Hi to I2, Sn plus 2 to Sn plus 4, FeS2, FeSO4. These reactions are very important for competitive examinations. For any competitive examinations, either NEET or JEE, these reactions are very important. Hope it is clear. So in all of these reactions, if you observe it, HNO3 can act as a, it can act as a oxidizing agent. It can act as a oxidizing agent. Once you can check the reactions, if it is clear, you can take the screenshot. Right, I am erasing. Now let's move on to the next one, that is reaction with metals. Reaction with metals. We are going to talk about the second reaction, that is reaction with metal. Children, nitric acid reacts with most of the metals. Most of the metals except with noble metals. Except with noble metals. Except with noble metals, it can react with most of the metals, right? So noble metals means like gold and platinum. It cannot react with the gold and platinum. So now, if you observe it, towards its reaction with metals, HNO3 can act as a acid as well as oxidizing agent, right? Whenever it is reacting with metal, in such cases, it can act as a acid as well as oxidizing agent. It can act as a acid as well as oxidizing agent. Hope it is clear. So we will be talking about those metals reactions, very important reactions we are going to talk about. First one with copper. First one with copper. It is the metal placed below the hydrogen in electrochemical series. Metals placed below the hydrogen in electrochemical series are like copper, silver, right? Copper, silver, if you take it, all those will react in the similar manner. All those will react within similar manner. I repeat it. Metals placed below the hydrogen in the electrochemical series. Metals placed below hydrogen in electrochemical series. In electrochemical series, they can react in the similar manner. What are the metals? Copper, silver, mercury. All those they react in the similar manner. So I'll be discussing only one metal, that is copper, and the reaction which is similar reaction will be applicable for remaining metals also, like silver and mercury. So now let's see with copper. So as you know, whenever metal react with acid, it forms metal salt. Copper is reacting with two types of acids. First is dilute HNO3. First is dilute HNO3. So whenever metal react with acid, as you know, it gives the metal salt. It gives the metal salt. So you will get copper whenever it is treated with nitric acid, it will give copper nitrate. That doesn't make any difference. But what is the utmost important point here? What are the products you will be getting? Nitrogen oxides, what you are getting is very important. Copper with metal copper dilute HNO3, it gives nitric oxide, which gives nitric oxide, and with concentrated nitric acid it will give nitrogen dioxide. It gives nitrogen dioxide. Observe it carefully, children. It's very important, especially for competitive exams. They will ask you these products only. They will ask you those NO as well as NO2. So it would be somehow difficult to remember, right? So in such cases, I'll be giving a short trick for it. What is the trick to remember? So I am talking about with copper, Cu. Okay, with copper, when we talk about it, you know that metal salt means copper nitrate plus water. But which oxide of nitrogen? Right? Which oxide of nitrogen? It's very simple. First take dilute, then take concentrated acid. Okay. Nitrogen number remains constant. Oxygen number increases. With dilute HNO3 it gives NO. With concentrated HNO3 NO2. What you have to say? Nitrogen number remains constant. Increase the oxygen number with copper. Okay. So similar reaction is for Ag as well as for mercury. With Ag plus dilute HNO3, NO plus H2O, AgNO3. Ag plus concentrated HNO3, NO2 plus H2O, AgNO3. Similarly, mercury plus dilute HNO3, mercury plus concentrated HNO3 gives the same products. Understood the point? Is it clear for you? It's interesting, no? Right? How is it? See, with concentrated nitric acid, NO2, nitrogen dioxide you will get it. I repeat, with copper, if it is dilute HNO3, first take dilute HNO3, second concentrate HNO3. In both of the cases, nitrogen number is same. Oxygen number increases. Such a way you have to remember. Clear? Next, with zinc. With zinc in the sense, this is the metal placed above the electrochemical series. Placed above the electrochemical series. Okay. So, and when we talk about it, the same tip is not applicable here. The same trick is not applicable here. Just observe it carefully. With zinc, metal plus acid gives metal salt. Zinc plus dilute HNO3 and zinc plus concentrated HNO3. Zinc plus concentrated HNO3. Observe it carefully. Whenever zinc reacts with dilute HNO3, it gives zinc nitrate. It is common. With concentrated nitric acid also zinc nitrate. But now here N2 and NO2. When we discuss, these two reactions simultaneously, you will get confused. That's why, what is the trick here? With zinc, when we talk about it here, nitrogen, nitrogen, oxygen, oxygen. Oxygen number increases. Nitrogen number decreases. With dilute HNO3, it is N2. With concentrated HNO3, N1 only. Dilute HNO3, O1 only, but concentrated HNO3, NO2. Such a way you have to remember. Understood the point? Is it clear for you? So, zinc, dilute HNO3. It gives you zinc nitrate plus N2O, nitrous oxide, also called as laughing gas, plus H2O. Zn plus concentrated nitric acid gives you zinc nitrate plus nitrogen dioxide plus H2O. Is it clear for you? Yes or no? Is it clear? So, almost remaining metals which are placed above the hydrogen in the electrochemical series react in the similar manner. Understood the point? Is it clear for you? Like you can take tin, you can take iron. Tin and iron also react in the similar manner. I am not writing all the reactions. Tin and iron also react in the similar manner. Hope you understand. Is it clear for you? Very important reactions these are. Now, when we talk about non-metals, right? Still, non-metals when we talk about it is. So, how it can react with the non-metals, right? With phosphorus in the sense it is non-metal only. Yes, sir. Non-metal plus acid, it will give an acid. See, all these are examples of non-metals. I am taking. Observe it carefully. With non-metals. Whenever you take non-metals, children, in all of these, NO2 plus H2O is common. NO2 plus H2O is common. So, how we have to remember, if I take phosphorus, it gives phosphoric acid. If I take iodine, it gives iodic acid. Phosphorus gives phosphoric acid. Iodine gives iodic acid. Similarly, sulfur gives sulfuric acid. Carbon gives carbon dioxide. Sulfur gives sulfuric acid. Carbon gives carbon dioxide. Okay. So, check those reactions once again. We will go back. We'll go back, just check here. Phosphorus P4 plus 20 moles of HNO3, it gives phosphoric acid plus NO2 plus H2. Nitrogen dioxide plus water, these are the common products in all of these reactions. So they will ask you in such a way, phosphorus can be converted into phosphoric acid. Iodine plus 10HNO3, HiO3. Iodine can be converted into iodic acid plus NO2 plus H2. Right? Hope you understand the reactions. Similarly, check it. Sulfur can be converted into sulfuric acid plus NO2 plus H16H2. Carbon plus hot concentrated HNO3, it gives CO2 plus H2O plus NO2. Carbon can be oxidized to CO2. Is it clear? So, we have discussed nitric acid reaction with the metals. Under that, metals below the hydrogen and electrochemical series like copper, silver, mercury, and as well as second category, metals above the electrochemical series. Sorry, metals above the hydrogen and electrochemical series like zinc, iron, tin. All those they react in the similar manner. Corresponding metal salt will be obtained. Now, second category, what we have? Reaction with non-metals. Reaction with non-metals. Phosphorus gives phosphoric acid, iodine gives iodic acid, sulfur gives sulfuric acid, carbon gives carbon dioxide. Understood? It's very simple. I'm just summarizing it. Clear? So before discussing it, so I'll be concluding with another point here. So now reaction with metals and non-metals is done now. Metals which become passive in HNO3. Passive in HNO3. See, whenever few metals, if I take it, right, few metals like cobalt, nickel, chromium, aluminum. So they will ask you why chromium, aluminum do not react with concentrated nitric acid. Such a way they will ask you the question. It is because of these are the metals which are placed above the hydrogen electrochemical series, most reactive metals, but they cannot react with the concentrated nitric acid because of the reason concentrated nitric acid act as oxidizing agent. No, so due to the formation of thin metal film of metal oxide on the surface of the metal, these metals do not react with concentrated HNO3. They become passive. Passive means inert. They cannot react, right? So it is due to the formation of a thin film of metal oxide on the surface of a metal. On the surface of a metal, it forms a thin film of metal oxide. Because of it, cobalt, nickel, chromium, aluminum becomes rendered passive due to the formation of thin film of metal oxide. Even iron also, however, becomes passive in highly concentrated HNO3. Sometimes iron becomes passive in highly concentrated HNO3, means 80% concentrated HNO3, but it can react with dilute HNO3. Very dilute HNO3 only can react with iron, but 80% concentrated HNO3 means it becomes rendered passive. Understood the point? And now metals which do not react. What are the metals which do not react, children? Platinum, gold, iridium, IR, rhodium, RH. They do not react with nitric acid, but they dissolve in aqua regia. Aqua regia is nothing but 3:1 of HCl and HNO3, means 3 parts of HCl, 1 part of nitric acid. Right? They dissolve in the aqua regia, which gives nascent chlorine. Hope you understand. If I take, let us say, HNO3. plus platinum plus HCl. Mixture of HNO3 plus HCl is aqua regia. Understood? It gives you H2PtCl6 hexachloroplatinate, right? Hexachloroplatinate ion or chloroplatinic acid plus NOCl plus H2. If you balance it, you will get 4 here, right? So of course the reaction is balanced. Similarly with gold also, if I take it, HNO3 plus AU means gold, HCl 3, if you balance it, you will get chloroauric acid. Previous one is chloroplatinic acid, it is chloroauric acid. If you balance, you will get 2 here, and it is 3 NOCl, nitrosyl chloride plus 6H2O, you will get it. Means platinum and gold individually they do not react with nitric acid, but they dissolve in aqua regia, that is mixture of HCl and HNO3. 3 parts of HCl and 1 part of HNO3 is called as aqua regia, right? So, but if you take individually only concentrated nitric acid, that concentrated nitric acid cannot dissolve noble metals. But aqua regia, if you take it, that is HNO3 plus HCl, 1 part of HNO3, 3 parts of HCl, it gives NOCl, nitrosyl chloride plus 2H2O plus 2Cl. It liberates the nascent oxygens. Due to the liberation of this nascent chlorines, it can strongly oxidize even noble metal also. Understood? Is it clear for you? Right? So it's all about reaction with metals, non-metals. This is a very important part for competitor. Just make a look on it. Just make a look on it. I'll summarize the points also even. I'll be erasing it. Fine. Now let's talk about very important brown ring test. Very important brown ring test. It's very important for practical examinations also. Very important for practical examination also. Children, when you go to the laboratory, if they give any salts containing nitrate ion, salts containing nitrate ion, NO3 minus. In such cases, you can perform a confirmatory test that is called as brown rings test. Understood? So, actually it is a brown ring test for nitrates, depends on the ability of Fe2 plus to reduce nitrates to nitric acid. Nitrates to nitric oxide, nitrates to nitric oxide. So what you will do, this test actually used to carry out in a test tube. If you take it, you will add a salt solution. That salt is consisting of nitrate, and you will add FeSO4, freshly prepared FeSO4 solution. You will add it. Just excuse me. So you will add a freshly prepared FeSO4 solution. You will take salt solution and you will add freshly prepared FeSO4 solution. Understood? And upon adding freshly prepared FeSO4 solution, along the walls of the test tube, you have to add concentrated sulfuric acid. Then you will get a brown colored ring. So you will get a brown color ring upon adding the concentrated sulfuric acid. So a brown colored ring can be obtained at the interface between the solution and sulfuric acid layers, indicates the presence of which ion? Nitrate ion. A brown colored ring can be obtained at the junction of two liquids. So if you observe that, so we are adding FeSO4. That FeSO4 in which iron is existing in the form of Fe2 plus, a salt is consisting of NO3 minus. So this Fe2 plus converts NO3 minus to NO, right? And that NO furtherly reacts with that iron complex, right? That iron complex FeH2O6 2 plus it gives you FeH2 of 5 times NO whole raised to 2 plus, right, plus H2, and it is called as brown ring complex. Sometimes they will ask you the formula of the brown ring. They will ask you the formula of the brown ring. So this is the formula you have to remember. FeH2 of 5 times NO whole raised to 2 plus. It is the formula of the brown ring, children. Very, very important. Once check it, everyone. Is it clear for you? Is it clear? Right? So this is we had discussed just now. So far, if you observe it, children, we had discussed about acidic nature of the nitric acid as well as oxidizing nature. Now we will be talking about nitrating agent. It can act as a nitrating agent, which are well familiar reactions. Benzene undergoing treatment with nitration mixture. It is a mixture of concentrate sulfuric acid plus concentrate nitric acid. Okay, it gives nitrobenzene plus H2. Nitrobenzene plus H2. This reaction is called nitration. In this, concentrated nitric acid is acting as a nitrating agent. It can act as a nitrating agent. Similarly, if you take toluene, toluene means I have taken, see, if you observe it here, you will get a mononitro product if you take less than 60, but here I have taken greater than 60 degrees Celsius. Means high temperature I have applied, so all the ortho and para positions are occupied by nitro groups. It gives 2, 4, 6 trinitrotoluene. When toluene reacts with concentrated nitric acid, it gives 2, 4, 6 trinitrotoluene. Clear? Similarly with phenol also, concentrated nitric acid plus concentrated sulfuric acid, it gives 2, 4, 6 trinitrophenol, which is commonly known as picric acid, one of the strongest acid. So nitro groups are generally responsible for the explosiveness of the compound. Because of more number of NO2 groups, it can be called as an explosive also. So first is with benzene, next is with toluene, and next is with phenol. So phenol, whenever it reacts with nitration mixture, it is a mixture of concentrated HNO3 and concentrated H2SO4. It gives 2, 4, 6 trinitrophenol, which is commonly known as picric acid. In all of these reactions, children, it is acting as a nitrating agent only. It is acting as a nitrating agent. Understood? With cane sugar, I have done it at this reaction, it gives oxalic acid. And those reactions gives you oxidizing nature. Those reactions gives you oxidizing nature. That is done. Yes or no? See, if you observe the uses, before solving MCQs, observe the uses of nitric acid. Uses of nitric acid. So nitric acid especially used for manufacture of ammonium nitrate. Okay, for fertilizers, especially for fertilizers, ammonium nitrate is required, and other nitrates for use in explosives. Other nitrates for use in explosives. Okay, so as well as other explosives, like it can be used in the preparation of trinitroglycerin, that is TNG, full form is trinitroglycerin. Okay, as well as trinitrotoluene, TNT. All these are somehow explosives, children. And as well as other major uses are pickling of stainless steel. Pickling of stainless steel. As well as it can be used in etching of metal. Means in both these cases it can prevent it from oxidation. It forms a protective layer on the surface of metals or as on the surface of the steel. Because of it, it can protect it from the oxidation reactions. So that's the reason concentrated nitric acid can be used for pickling of stainless steel, as well as it can be used in the etching of the metal. Okay, so now, so all these are the examples, all these are the all these are the uses of the nitric acid, children. All these are the uses of the nitric acid. Okay. So sometimes even pickling, generally the process when it comes to food items, it is applicable to the food items, that is different case. Okay. Right. Let's solve some MCQs and then we will summarize the topic. Aqua regia is 1:3 mixture of 1 part of HNO3, 3 parts of HCl. That is aqua regia. Nitrating mixture, concentrated H2SO4 and concentrated HNO3. Brown ring test is done for which group anion? NO3 minus. In this reaction, actually HNO3 can act as oxidizing agent. It can oxidize the carbon to carbon dioxide. So option B is the correct answer. Clear? So it's a very important topic, children. Under nitric acid, it can behave as an acid and it can behave as a oxidizing agent. Acidic nature means any reaction you can write it with base. Oxidizing agent in the sense, what are the reactions we have taken? So many compounds, oxidation of compounds I have taken, like Fe2 plus 2, Fe3 plus H2S2 S, SnCl2 to SnCl4, like that. Reaction with metals. Under this, metals below hydrogen in electrochemical series. Electrochemical series. And reaction with metals above hydrogen in electrochemical series. Similarly, reaction with non-metals. Under metals, we have discussed reaction with noble metals also. Under that, reaction with certain metals becomes passive. Metals become passive with concentrated nitric acid. All these reactions we have done. Reaction with metals means phosphorus to phosphoric acid, iodine to iodic acid, carbon to carbon dioxide, sulfur to sulfuric acid. And as well as uses also we have discussed. This is all about nitric acid. Please revise it. It's a very important topic for both PU as well as CBSE boards as well as for competitive. Of course, for class 12 from CBSE, they have been removed this chapter, class 12. From class 12, this group 15 elements, they have been removed. Is it clear? So, but for competitive it is there. No need to worry about it. Hope you like the video. If you like it, please click on the like button. Still, if you have any doubts, you can post it in the comment box. If you haven't subscribed to my channel, please subscribe to my channel and share it to your friends. And we will be uploading the videos here onwards, and we'll try to complete the group 15 by the end of this week. Okay, we will meet you in the next video or in the next session. Until then, take care. Signing off. Bye bye.